Hello everyone, welcome back to my video tutorial. This time I will be talking about three-dimensional modeling transformations. What is three-dimensional modeling transformation? It is a method for object modeling transformation in three dimensions are extended from two-dimensional method by including consideration for the z-coordinate. Previously we talked about two-dimensional. In two-dimensional we have x and y coordinate. Here in three-dimensional, we will have another coordinate which will be z. Okay. Now, what three-dimensional modeling transformation does is that it generalizes from 2D by including the z coordinate. Straightforward for translation and scale, rotation more difficult. So for translation and scaling, it is quite straightforward. So rotation, it will be a little bit complex. Okay. Homogeneous coordinate will have four components. In two-dimensional modeling, for homogeneous coordinates, we have three components. For 2D, we have three components. Here we will have four components. Okay. If we have four components, the transformation matrices will also be 4 into 4 elements. All right. We will consider points as column vectors. Thus, a typical point with coordinate x, y, and z is represented as this. All right. Here we have x, y, and z as a column vectors. This is column, so it will have a column vector. A 3D point P is represented in homogeneous coordinates by a four-dimensional vector. Here we will include 1. Just like we have in two-dimensional, we have x, y, and 1 for homogeneous coordinates. In this case, we will include z, and then we will have 1 here. So we will have four-dimensional vector. Why do we want 3D point homogeneous coordinates is we don't lose anything. The main advantage is that it is easier to compose translation and rotation. Everything is matrix multiplication. This is the best thing. So we don't have to put something like addition here. All right. So in homogeneous, this addition will be cancelled by multiplication. We will have a matrix here, translation matrix here, and we'll simply have x, y, z in 1 here. Now 3D coordinate system, if we use a right hand system, we will have x exists here, y exists here, and z exists here. And as you can see from this, x, y, and z. If we use the left hand coordinate system, we will have x, y, and z on the other side. All right. So these are the two types of coordinate system. In homogeneous coordinates, 3D transformation are represented by 4 by 4 matrices, as you can see from here. This is your transformation parameters, and here is your value. Okay. We have 3D translation and scaling and then rotation. Now the first one is translation. In 3D translation, P is translated to P dash by these matrices. Here x dash is your new coordinates. Here x is your old coordinate, and then this is your translation matrices. Actually, this, if we multiply this, x dash will be equals to tx plus x, y dash will be equals to ty plus y, and z dash will be equals to tz plus z. Okay, this is your formula. But when we put it into homogeneous matrices, it will come up like this. And if you multiply this, you will get the same answer. All right. An object is translated in 3D dimensional by transforming each of the defining points of the objects. So all these points here and all these points will be translated, and then we will translate the object into another coordinate system in 3 dimensions. All right. An object represented as a set of polygon surface is translated by translate each vertex of each surface and redraw the polygon facets in the new position. So here we have, this is your old coordinate on the x, y, and z plane, and then this is your translation parameters. and here will be your new x dash, y dash, and z dash. Okay. Now let us give an example. Given a 3D object with coordinate points A 031, B 332, C 300, D 000, apply the translation with the distance 1 towards x-axis, 1 towards y-axis, and 2 towards z-axis, and obtain the new coordinates of the object. Alright, so when we have an object of the coordinate system like this, so here we know that tx will be 1, ty will be 1, and tz will be true. Alright, this is the value that we have. So for point A, considering point A 031, when we translate this, we will have x dash for this particular point will be your old x, here will be x plus dx. Alright, so here we will have 0 plus, this is your 0, 0 plus 1, your x dash will be 1. Likewise, your y dash will be 3 plus 1, which will be 4, and z dash will be 1 plus 2, which is 3. Alright, so your point A dash will have 1, 4, and 3. So if we consider point B 3, 3, 2 here, let me put line here. So your x dash will be 3 plus 1, which is equals to 4. Y dash will be 3 plus 2, which will be equals to 5. So 3 plus 1, which will be equals to 4 again. And z dash will be equals to 2 plus 2, which will be equals to 4. Alright, so your point B dash will be 4, 4, 4. Now consider point C 3, 0, 0. Here we will have x dash will be equals to 3 plus 1, which is 4. Y dash will be equals to 0 plus 1, which is 1. And z dash will be equals to 0 plus 2, which will be 2. Now your point C dash will be, your new point will be 4, 1, 2. Now let us consider point D, which is 0, 0, 0. Now your x dash will be 0 plus 1, which is 1. Y dash will be 0 plus 1, which is 1. And z dash will be 0 plus 2, which is 2. Alright. And your d dash, your new point for d dash will be 1, 1, and 2. So we will have a new point which will be, let me write it here, A dash 1, 4, 3, B dash 4, 4, 4, C dash 4, 1, 2, and D dash 1, 1, 2. Okay, so that is all for 3D translation. See you on the next class. Thank you.